Hey guys, this is Carrie, and this is the answer key video for homework number 3. So we're going to start off with problem number 1, solve the following equation for all values of x. If necessary, make sure that your answer is in simplest radical form. So my instinct with this one would always be to go to factoring. I love factoring. So I noticed that they have a GCF of 4. I factor that out, and I'm left with this. So even though my instinct was to go to factoring, I'm seeing that I'm supposed to use sum and product here, and I'm looking for two things that sum to 10 and have a product of -4, and nothing comes to mind. The only things that multiply -4 are 2 and 2, and those aren't going to add to 10, or 4 and 1, and those aren't going to add to 10. So factoring kind of leaves us stuck. So it'd be better to take an alternative approach to solving this problem. So we've learned when factoring doesn't work that oftentimes if you had a different number here, things might work out better. So we can't use that technique unless we have no 4 there, so we can divide through by that 4 on both sides, and we divide each term by 4, giving us 4x squared plus 40 over 4 is 10x, 16 over 4 is -4, equal to 0. And we end up with the same thing we had with the sum and product, but the advantage here is, since we don't like having the -4 there, we can pop that -4 out on both sides, and that will give us x squared plus 10x, with something missing there, equals 4. And now we can put a better number there than the number that we had before, just like you guys have been doing kind of the last 2 lessons. So thinking ahead, when we factor this, we want to end up with the same number here and here. That number has to add to 10 and multiply to this, so it looks like it's going to be 5 and 5, because 5 plus 5 is 10. But then we want to have a 25 here, so that they have the proper multiplying, and we want to have a 25 here, so that we have the proper multiplying, and that will be 29. So now we get x plus 5 all squared equals 29, and we write the answer down as -5 plus or minus the square root of 29. Notice that this is 2 answers because we had the highest power of 2, and it all looks good. So, using Desmos, graph this parabola. Alright, I'm going to assume that you guys are going to do all this on your own because we reviewed this in the last homework. We also reviewed it in the do now, so no worries. So hopefully you guys have it. For problem number 3, what is the y-intercept of this function? So one of the things that you might have seen when you were graphing the last one on Desmos is no matter where this parabola hits the y-axis, because you haven't moved left or right, I said that backwards, at all, the x-coordinate of this point is going to be 0. So even though we don't know the y-coordinate, we're guaranteed that the x-coordinate is 0 because it's on the y-axis. It hasn't moved left or right. So to find the y-intercept, you plug in x-coordinate of 0. And so that becomes y equals 3 times 0 squared minus 15 times 0 minus 18. 0, 0, y is equal to -18. And so our y-intercept for part A is -18. For part B, what are the x-intercepts of this function? So to find the x-intercepts of this function, thinking about the x-intercepts, you haven't moved up or down at all. So because you haven't moved up or down, you know that the y-coordinate of these points will be 0. So you plug in, to find the x-intercepts, you plug in y equals 0. Just like you had in the points. So 0 is equal to 3x squared minus 15x minus 18. Divide through by 3 on both sides. 0 is equal to x squared minus 5x, because this is a 3, minus 6. Sum and product works really well here, and you get x equals 6 or x equals -1. Wow, okay. So there's a connection here between the x-intercepts and the factors. So if you factor it, you can see that your x-intercepts come from the factors. We saw this in class yesterday, or today actually. I don't know why I said yesterday. So let's see if we can apply that here. So write a function that has x-intercepts at only these values. So y is equal to get 6 as an x-intercept, we saw that the factor had to be x minus 6. To get -5 as an x-intercept, the factor had to be the opposite, plus 5, opposite minus 1, and opposite plus 3. So now you should check that on Desmos and verify that this works. I'll actually do that for you as well. There's something nice to see here. Y equals x minus 6 times x plus 5. And one of the nice things about doing this on Desmos is you can start to see those x-intercepts pop up right away as you write the factors. And if we include all of them, minus 1 and plus 3, we should get the last two. So x minus 1 and x plus 3. So let's verify it. -5, -3, +1, +6. Is that what we wanted? It is. So Desmos has proven that it works. Now the reason why I wanted to show you this one is actually something interesting happens here. If you put any number in front of this, like 5 or 9 or 0.5, it actually has the exact same x-intercepts. And so because you can put any number here, it's actually impossible to find the exact right equation. There are infinitely many possible equations that work. The factors have to be what we wrote, but any number could go where we have the 0.5. It could be 1.356. It's still the same factor, the same x-intercepts. It could be 3.14. It's still the same x-intercepts. So let me show you how that comes into play with problem 6. I think it's 6. Problem 5. So for problem 5, it says a parabola has x-intercepts at -5 and 2. So we know that it's going to have these factors because those give us the x-intercepts. But it also passes through this point. And the reason why I left a space here is we just saw in Desmos that any number could go here. So we could put a 7, we could put a 4, we could put a -3, we could put a 3.14. We could put any number there. So because we don't know what number goes there yet, we put a there. And the reason why we put a there is if you distribute it out, you get ax squared plus bx plus c like we saw earlier with standard form. And what we're going to do is we're going to find out how much a has to be for this specific problem. Now the one piece of information that we haven't used yet is we haven't used the fact that it goes through this point. So let's plug in this point to find a. So to plug in that point to find a, we get 12 equals a times -2 plus 5, because we're plugging this in for x, this in for y, -2 minus 2. 12 is equal to a times -3, that's not right, +3, times -4. 12 is equal to a times -12. So the last step to solve for a is to divide by -12 on both sides, and that gives us a is equal to -1. So our final equation must have been y equals -1 times x plus 5 times x minus 2. When your answer to question 4 is expanded into standard form, what are the values of a, b, and c? So currently this is in something called factored form because it's been completely factored. We want to turn this into standard form, so it's okay. We want to turn this into standard form. I'm just going to leave it because it sounds... That's a water bottle being filled. It's not someone peeing in the background. Sorry. It's okay. So hopefully you guys heard what I'm talking about. Otherwise it sounds crazy. So to expand this, you're going to distribute out the x plus 5 times the x minus 2. That gives you y equals -1 times x squared minus 2x plus 5x minus 10. And back to the same room. Y equals -1 times x squared plus 3x minus 10. Y equals, now distributing this, -x squared minus 3x plus 10. So picking it out the values of a has to be -1, b has to be -3, and c has to be 10. Just matching it up with the y equals ax squared plus bx plus c form. Alright, so hopefully you guys found this helpful, and I'll see you in class tomorrow.